Hello everyone. Today we are in the chapter 7 and we will discuss about transmission media. The transmission media is a medium how to transmit the data. In transmission media can be broadly defined as anything that can carry information from of a source to the destination. For example, the transmission media for two peoples are having dinner and conversation in their air. So this is known as the transmission media. The transmission media and the physical layer. The transmission media starts with the physical layer because physical layer is the last level of OSI model. The sender physical layer and receiver's physical layer are connected with the transmission media. Those media can be cabled or wired. In this transmission media section, we have guided and unguided. Guided are wired media, which are twisted pair cable, coaxial cable, and fiber opticals. And unguided are radio waves, microwaves, and infrared. The difference between guided and unguided media are given below. Guided media can transform by the electromagnetic waves in the physical conditions, and the unguided media are not guided. Here the physical paths are for transmission, but unguided media don't have any physical path. It is called the wired communication, but unguided media is not wired. The examples of physical media is given and the unguided media is given here. Now the guided media. It has some parts or types. Suppose we have in the twisted pair cables. In this twisted pair cables, why it is called the twisted pair, you can see in this diagram that those wires are twisted to each other. That is why this is called the twisted pair cable. Here we have the insulator section, which is the outside rubber, and the conductor is the main wire in the twisted pair cable. The twisted pair cable have two conditions, UTP and STP. UTP stands for unshielded twisted pair cable. In this section you can see that the cables are shielded with only just a plastic cover, which is known as the unshielded twisted pair cables, and the shielded twisted pair cables have a metallic shield inside the plastic cover is known as the shielded twisted pair cable. So this is the difference between unshielded and shielded twisted pair cable. The difference between shielded and unshielded twisted pair cable is given here. The main difference is shielded twisted pair cable is very much costly, but it is very much reliable, but unshielded is not that much expensive, but it is not very much reliable because unshielded twisted pair cable can conducted with the noise. Unshielded twisted pair cable is used in the LAN section, but the shielded twisted pair cable is used in the metropolitan area network or MAN section. The criteria of unshielded twisted pair cable is given here. The connector of UTP, which is unshielded twisted pair cable, we have RJ ports. RJ45 have two ports. One is the female port and another one is the male port. The male port is the port that we use for our internet or data transfer in our PC or laptops, and the female ports are those ports where we put the male port is known as the female port of UTP. The performances diagram is given below. The application of twisted pair cables are given here. The basic application of twisted pair cables which we use in our home, that is our internet or broadband cable, which are connected with our modem, routers, and our PCs. In this section we obviously use the ISDN, which stands for Integrated Services Digital Network. Now the coaxial cable. In the coaxial cable we have first the plastic cover, then the insulator, then the outer conductor, which is the shield section, and then again an insulator, and lastly we have the inner conductor. This coaxial cable that we used in our cable TV. The wire we used in our cable TV is known as the coaxial cable. The coaxial cable's standards and the categories are given below. The coaxial cable have three type of connector, which is BNC, BNC T. First one is the BNC, which is the BNC connector, and then it looks like T, so it is called the BNC T connector, and last one is the BNC terminator. Terminator means that it terminates the connection, so it is called as the BNC terminator. You can have a snap of this one. The diagram of performance graph is given. We have already discussed about application of coaxial cables, that coaxial cables are basically used in our TV network sections. Now the most important parts in cabling is the fiber optics. In fiber optical cable is made of glass and plastic for transmitting data at the speed of light. So the fiber optical cost is very high. In the center section we have to send some lights, and here we use the glasses to reflect the lights through this cable. We have cladding, and inside that we have the core section. So this is the diagram of fiber optical cable. Propagation mode, we have multimode and single mode, but in the multimode we have two types. One is step index and grounded index. In multimode section we have a source, and the multiple lines of lights are going through is known as the multiple step index, and multimode grounded index is going like a waveform. Then the single mode, where the cladding is very much thin, and from this the light goes straight to the destination, is known as the single mode. Different types and sizes of fiber optical, the table is given here. The cable capacity and the other stuffs are given here. The fiber optical connectors are very important. You can have a snap of these connectors. One is SC connector, ST connector, MT-RJ connector. Here MT-RJ connector is basically more usable than any others. The performances graph is given here. The application of fiber optical is basically used on fast Ethernet, on internet and broadband services. The advantages of fiber optical are very much high, which is higher bandwidth with lesser signal attenuation or noise. The immunity is high. The resistance to corrosive materials are high. The lightweight and the generate immunity to taping is high in fiber optical cables. The disadvantages are basically the fiber optical is very costly, so this is the major disadvantage of fiber optical cables. The difference between cables are given in this diagram or table. You can have a snap of this one, and the advantages and disadvantages are given also. Now we are entering into unguided media. In unguided media we have frequency range from 3 kHz to 300 GHz is for the radio wave or microwave, and the infrared is for 300 to 400 terahertz, and then 400 to 900 terahertz is for the light waves. We already know what is radio wave because already we have used radio in our home, and already know about microwave by the microwave ovens. But infrared is the light that we have in front of our TV remote, where when we press a button in the TV remote a light blinks, which is the infrared light. Now The propagation methods are grounded propagation, sky propagation, and line side propagation. The grounded propagation looks like this one. The sky propagation looks like the antenna sends the signal to the sky, then the station sends to the next one, and then ISO or line of state is looks like this. This antenna are connected face to face condition. The frequencies are given below. Here are some stuff of ground propagation, sky propagation, and line propagations. Here are types of wireless transmission, where we will discuss about the radio waves. About some radio waves and applications are given here. You can have a snap of this. The radio frequency is basically from 3 kilohertz to 1 gigahertz. The microwave frequency is between 1 to 300 gigahertz is called as microwave. The categories of microwave are given here. Several types of antennas. In this section we will discuss about omnidirectional antenna, which will looks like this, and always it flows the signal to all around this. The unidirectional is to focus on one side. This is called the unidirectional antenna. There are two types: parabolic dish, which is this one, and the horn type, which looks like this one. The parabolic dish are already we have seen in like as dish antenna. Application of microwave are given here. The infrared works on 300 gigahertz to 4000 terahertz. The application of infrared are now terminal imaging, light, night vision, health taking and heating, tracking, and etc. I will give the link of this presentation in the description box. Please check that one. Thank you.